Good afternoon. Right now we're starting lesson 16, which is applying the Pythagorean theorem. Example 1 says, the triangle below is a right triangle. The hypotenuse, which we know is across from the right angle, has a length of 13 units, right here, and a leg with the length of 5 units. Determine the length of the other leg. Right now what I'm going to do is I always start off by labeling my triangle. I know that the hypotenuse is always C, so go ahead and label that C. And then I get to choose which of my legs is A and which is B. I'm just going to make this one A and this one B. Now we know that our Pythagorean theorem says a squared plus b squared equals c squared. Since we know a is 5, instead of a squared we wrote 5 squared. We still don't know what b is, so we just left it as b squared. But we know what c is, it's 13, so we did 13 squared. Now I know that 5 squared is 5 times 5, it's 25. I still don't know my b squared, so I'm going to leave it as b squared. And I know 13 times 13 is 169. I just used my calculator for that, and it's fine for you guys to do that as well. But so then I end up with 25 plus b squared equals 169. So now I need to figure out 25 plus what equals 169. So I'm going to do 169 minus 25. I get 144. So that means b squared right here is equal to 144. But I'm not done yet because I know b doesn't equal 144. That doesn't seem reasonable. If this is 13 and this is 5, this is probably not 144. We've got to do the square root, and we get b equals something times itself equals 144. Ooh, I know 12 times itself equals 144. So b equals 12. If you need more time with this, you can go ahead and pause the video. If not, exercise 1. Use the Pythagorean theorem to find the missing length of the leg in the right triangle. Again, I'm going to start out by labeling my triangle. The hypotenuse, which is across from the right angle, is C. And I'm going to label this side A and this leg B. But that doesn't really matter. I could have switched it. I'm going to start off by writing my Pythagorean theorem. A squared plus b squared equals c squared. Now I'm going to go ahead and start filling in what I already know. I know what a equals. A is 15. It's going to be 15 squared. Plus, I don't know what b equals, so I'm just going to leave it as b squared. And I know what c equals. C equals 25, so I'm going to write 25 squared. Okay, so now I'm going to start figuring some things out. 15 squared is 15 times 15. I did that on my calculator. It's 225. Plus, still don't know what b squared is, so I can't figure it out yet. So I'll just leave it as b squared equals 25 squared, which is 25 times 25. My calculator tells me that is 625. So now I know that 225 plus b squared equals 625. So I need to figure out 225 plus what equals 625. 225 plus what equals 625. So I'm going to do 625 minus 225. I will get 400. So that means b squared right here equals 400. But again, I'm not done yet, because I know b doesn't equal 400, because that doesn't make any sense. If this is 25 and this is 15, this cannot be 400. I need to do the square root of both sides, and I end up with b equals the square root of 400. Let's see, I'm trying to figure out, does something times something, or something times itself equal 400? Ooh, I know that 20 times 20 equals 400. So that means the square root of 400 is going to be 20. All right, we're going to do one last example together. So go ahead and flip the page to the back. Right here it says, find the length of segment AB. Now this is different because we're just looking at a line. We're not looking at a triangle or anything. So how are we supposed to figure out just the length of some diagonal line? If it was one of these lines, I could just count how many boxes. But when it's a diagonal like this, I can't count how many boxes it is. So what we can do to solve a problem like this is we can actually create a triangle. So I'm going to draw a triangle on it. And I'm going to start labeling these sides. I know the length, now actually I've created a right triangle, so let's go ahead and label this right angle. And let's go ahead, since it's a triangle, I'm going to start by labeling my sides. Across from the right angle is my hypotenuse, which is C. I'll label this leg down here A, and this leg over here B. It doesn't really matter which one is which. I can see from the graph that A equals 3 because it's 1, 2, 3 boxes long. I can see that leg B is 4 boxes long. It's 1, 2, 3, 4. Still can't figure out C because it's a diagonal and I can't just count how many boxes. But I can use the Pythagorean theorem now to help me figure out what C is. So I'm going to write down a squared plus b squared equals c squared, because that's how I always start. And now I can start filling in what I know. I know a equals 3, so I'm going to write 3 squared, plus I see that b equals 4, so it's 4 squared, equals, I don't know what c is, so I'm going to leave it as c squared. Now I can start figuring some things out. 3 squared is 3 times 3, which equals 9, plus 4 squared is 4 times 4, that equals 16, equals c squared. Now I can go ahead and add these two together, because they're both on the left side of the equal sign. That equals 25. And again, I know I'm not done yet. I still need to do the square root of both sides. I know that C is going to be equal to the square root of 25. And so I'm thinking, what times itself equals 25? I know that 5 times 5 equals 25. So the square root of 25 equals 5. And that's how I could figure out the length of this line on a graph, by creating my own triangle to help me solve the problem. What you're going to do next is you are going to go through the rest of the packet and try to solve as many of the problems as you can in the amount of time we have left.